Hello, class. This is Mr. Hart. Sorry that I can't be there today. I am at a meeting for new teachers, so unfortunately I can't be there to teach the lesson, but I hopefully can get the information to you through this podcast that I'm doing. And so I want you to pay attention just as if I was in class. The homework will still be due next time, and we'll just treat it like it's a normal class day. Okay? But today we're going to be focusing on trig ratios. Oh, and I forgot to mention there's no quiz for today because I'm not there to set up Mastery Connect. So don't worry about the quiz. We're just going to skip it for 4.2. Okay. But today we're talking about trig ratios, which is 4.3. Okay. And to give us some background on trig ratios, let's look at some things we already know about triangles. Okay. So if we have this triangle right here. Okay. We know a lot about the sides of the triangle and the angles of the triangle. Okay. For example, we talked about last time how we know that there's this relationship between the sides of a right triangle that a squared plus b squared equals c squared. Okay. Pythagoras proved that. That's the Pythagorean theorem. We have this relationship between the sides of the triangle. Okay. We also know from our last unit that if we look at the angles of a triangle, we know that the angle of A plus the angle of B, let me use a different letter to separate. Maybe I'll just put alpha and beta and gamma equals 180. Okay. So last unit we talked about how if you look at the different angles of a triangle, these weird Greek symbols we can represent for angles, if we look at all the angles of a triangle, we know that they're always going to add up to 180. Okay, so we got this nice relationship between the sides of a triangle, we got this nice relationship between the angles of a triangle, but we haven't figured out any nice relationships between the sides and the angles, how they relate to each other. Okay, and so that's where trig ratios are going to come into play, because they help us relate an angle to the sides of a triangle. Okay, so again, we've looked at previously sides compared to sides, angles compared to angles. Now we're going to compare sides and angles. Okay, that's what the trig ratio does. Okay, so in this triangle down here, let's say we're looking at angle theta, which is this angle right here. Okay, and we want to be able to relate how big that angle is going to be compared to some of the other sides of a triangle. Okay, and so we came up with these terms that we use to describe how this angle is related to the sides of the triangle. Okay, because there's no direct relation, okay, between the angle and the sides and the hypotenuse and that type of thing. It's not just going to be like, oh, side over hypotenuse, gives you the angle, right? There's not a direct mathematical relationship. So we had to come up with our own functions, our own mathematical functions that give us this angle. Okay, and so let's just look at an example of one of them. One of them we call the sine of an angle. Okay, the sine of an angle, and it's shortened to be sin, which some people sometimes mispronounce as sin, but it's sine. Okay, that's what it means. If you look on your calculator, you probably have a sine button. Okay, but that function that we put into our calculator, okay, it has this direct relationship between what we call the opposite side of the triangle and the hypotenuse of a triangle. Okay, if we put in the opposite side and the hypotenuse of a triangle into this function, okay, that will give us the sine of the angle. Okay, so let me just go ahead and show you some of the trig ratios so you can kind of get an idea of what they represent and how we actually calculate them. Okay. Oops. All right, so let's look at the first set. There's actually 6 total. Okay. But the first one that we usually talk about is sine, like I was mentioning before. And we write it like this. Okay. The sine of the angle is equal to the opposite side of the angle compared to the hypotenuse of the triangle. Okay. So again, if we're looking at this triangle right here, and this is the angle we're looking at, okay, the side that is opposite this angle is this far side right here. Okay. And so let's just say we have a 3, 4, 5 triangle, just a standard right triangle. Okay, this side's length is 3, this side's length is 4, that side length is 5. Okay. Then the sine of this angle is going to be equal to the side opposite the angle compared to the hypotenuse of the angle. Okay. So in this case, if we have a standard 3, 4, 5 triangle, that would be equal to 3/5 in this case. Okay. So the sine of this angle is the opposite side 3 over 5, okay, the hypotenuse, which gives us 3/5. Okay. So next lesson we'll learn how we use this to find the sides of the triangle, but for now we just want to learn how we find these trig ratios because there's quite a few of them. Okay. All right, so the next ratio is the cosecant, okay, abbreviated CSC of the angle, and it's the exact same thing except the reciprocal. So it's the hypotenuse over the opposite. Okay, so in this case, we would get 5/3 because we got 5 divided by 3. Okay, hypotenuse divided by the side opposite. Okay, which will give us 5/3. Okay. So again, if you're not understanding quite yet what we're going to be using these for, don't worry. Just understand that we need this step to help us solve problems next time. Okay. So we're just identifying for now the sine and the cosecant, being able to understand what they're used for. Okay. So that's the first two. Okay. The next one is the cosecant. Okay. So not cosecant, cosine. And so the cosine of the angle is the adjacent side and the hypotenuse. Adjacent side over the hypotenuse. Okay. So again, if we're looking at this angle right here, we got our standard 3, 4, 5 triangle. Okay. Then in this case, the side adjacent to the angle, which is the side that is, the side that the angle is touching, that's not the hypotenuse. Okay. So we call this the opposite side because the angle is not touching it. This is the adjacent side because the angle is touching it, and this is always the hypotenuse. Okay. So in this case, if we're trying to find the cosine of this this triangle, okay, for this angle, then the adjacent side would be the 4, the hypotenuse would be 5, so the cosine would give us 4/5. Okay. And then we also have its reciprocal, which we just call secant, which we abbreviate SEC. And it is equal to the reciprocal hypotenuse over the adjacent. So in this case, that would be 5/4. Okay, 5 divided by 4. Okay. So that's our next set of trig ratios, the cosine and the secant. Okay, we got one more set that we need to know. And that is the tangent and cotangent. Okay. And so now this is the opposite over the adjacent, or the adjacent over the opposite. Okay. So again, looking at this angle, we got our standard 3, 4, 5 triangle. Okay. So opposite side for the tangent compared to the adjacent side of that angle. Okay. So tangent, abbreviated TAN, equals opposite over adjacent. So in this case, we would get that the tangent for this angle right here is 3/4, and then the cotangent is the reciprocal of that, okay, which we abbreviate COT, and that would give us 4/3. Okay, so adjacent over opposite. All right, so these are our different trig ratios. Okay, there's 6 in total. Okay, but most of the time people just think of the main 3 and their reciprocals separately. Okay, so sine, cosine, tangent, and the reciprocals, cosecant, secant, and cotangent. Okay. All right, so let's see if we can remember or figure out a way to remember this, because this is a lot of information. Okay. So there's a common phrase that for some reason always sticks in people's heads, and you can never forget it for some reason, okay? And the phrase is what we call Sohcahtoa, okay? And Sohcahtoa is a phrase that, every teacher uses, and for some reason it always sticks in everyone's head, okay? But it's an easy way to remember these trig ratios, okay? So Sohcahtoa is just a abbreviation, or just a, I don't know what the word is, a mnemonic. There we go. It's a mnemonic to help us remember these different trig ratios, okay? So the first letter is to help you remember what the word is actually called, right? So the first letter is S. That's supposed to help you remember that we're talking about sine, okay? Ka would be cosine, and then tangent would be, or T would be tangent, right? So we got our sine, our cosine, and our tangent, okay? And then the next two letters are to help you remember what you're talking about. So OH, okay? Let me rewrite this. So the sine is equal to OH, which is supposed to help you remember that it's opposite over hypotenuse. Okay. All right, and I'm realizing I'm going to run out of room really quickly, so let's move this over. Okay. So sine equals opposite over hypotenuse. So, okay, that's what's supposed to help you remember. Okay, sine is equal to opposite over hypotenuse. Okay. Then cosine equals AH, right, which is supposed to help you remember that it's adjacent over hypotenuse. And then TOA, right, tangent, is equal to opposite over adjacent. Okay. So this is again, this is a common mnemonic to help us remember, okay, what these trig ratios are. Sohcahtoa, okay, opposite over hypotenuse, okay, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and then tangent is opposite over adjacent TOA, okay? So I don't know why that sticks so well, okay, and you're going to be probably saying, well, this is, really dumb. Why would I ever use that mnemonic? Okay, but I promise you, you're probably going to remember that next lesson, okay? And so that's the way to remember the main three trig ratios, okay? And then the other ones are just the reciprocals of that, right? So cosecant was just hypotenuse over opposite. The secant was just hypotenuse over adjacent, and the cotangent was just adjacent over opposite, okay? So it's really easy to remember the other ones as well because you just take the reciprocals of these three, okay? But Sohcahtoa, remember that. It's an easy way to help you remember these different trig ratios, okay? Alrighty, so let's go ahead and take a look at a problem and get going with this, okay? So let's say we have a problem where we have a triangle like this, okay, and we're told to find the sine of the angle, okay, sine of angle alpha right here, okay. It could be cosine, it could be any one of the trig ratios, and we're just trying to, for now, we're just trying to find out what these are equal to. Then we'll use them to find angles and sides later, okay. But for now, we're just trying to figure out what is this actually equal to, okay. So we want to find sine of alpha, okay. So first thing we need to do is identify where alpha's at. Okay, and alpha's this guy right here. And so we know it's right there, and we want to figure out what sine is equal to. Well, sine of any angle, okay, or alpha, is going to be equal to, right, opposite over hypotenuse. Okay, so what we got to do is identify, okay, what's the opposite side to alpha and what's the hypotenuse, okay, for the triangle. Okay, so the opposite side for alpha is going to be this guy right here, okay, that's the opposite in this case. And then the hypotenuse isn't listed, okay, so before we can do anything, we have to figure out what the hypotenuse is, okay. Fortunately, last time we looked at the Pythagorean theorem, so we can actually figure this out from these two angles, okay? So before we move on, we're going to have to do that step, okay? So we're going to have to use a squared plus b squared equals c squared to figure this out, okay? So that's going to give us, let's see, a squared plus b squared equals c squared. That's going to give us 5 squared plus 8 squared gives us c squared. So that's going to give us 25 plus 64 gives us c squared. Okay, 25 plus 64 is, I believe, 89. Okay, 89 equals c squared. Okay, and then we square root both sides, and that will give us that this side, okay, c is equal to square root of 89. Okay. Now, last step is to check if it can be simplified. Okay, and at the moment, I'm not seeing any easy divisions we can do. Let me double check really quick though and make sure. Get out my calculator. Okay, so let's see if it divides by 3. Nope, doesn't divide by 3. Okay, we're going to see if it divides by, well, it doesn't divide by 2 or 5. Let's see if it divides by 7. No. Maybe 11. No. 13. 17. Okay, 23. No, okay, so I'm pretty sure that's a prime number. Okay. I apologize if I'm wrong on that, but I'm pretty sure that's a prime number. Okay. And so let's move on. Okay. So anyways, this is simplified as far as I'm aware. Okay. So now we can plug this directly back into this guy over here. Okay. So sine of alpha equals opposite over hypotenuse. So in this case, the sine of alpha is going to be equal to 5 over square root of 89. So sine of alpha is going to be equal to 5 over square root of 89. Okay? And there we go. So the sine of alpha equals 5 over square root 89. Okay, so once you identify all the sides, okay, identify which ones you're talking about. It's really simple. You just plug in opposite and hypotenuse. Okay. Or sorry, I don't know why I said 5. The opposite side for this triangle is 8. Okay. Opposite side is 8. Okay. So this would be 8 over square root 89. Okay. So this points out an error that often happens, okay, with students. Because we do all our diagrams showing this as being the opposite side, we have to be careful. Opposite doesn't necessarily mean the left side of the triangle. It means the side that is opposite the angle you're looking at. So in this case, the opposite is this side down here because it's opposite of this angle. Okay, if I was talking about beta, this angle over here, this one would be the opposite. Okay, so I just made that error, okay, which means it's very common to make this error, so be careful. Make sure you know which one you're talking about when you say opposite, okay? It's always specifically the one concerned with the angle, okay, not necessarily the triangle. So this angle's opposite is this one down here, okay? So there we go. Now we got it right. Okay, sine of alpha is 8 over square root 89, okay? All right, so go ahead. Try this one on your own, okay? Tangent of alpha, okay? So I'll give you about, shouldn't take too long. I'll give you about a minute, okay, to do this problem. Get the timer on my phone. I believe this is on your homework as well, so if you want to just do it on that page, that'd be great. Okay. If I can find the timer. Okay, so there you go. So got about a minute. Okay, so go ahead, try that on your own. Hopefully this is pretty easy to do, but do it on your own, and then we'll go through it. Alrighty. So let's see what you got. So with this problem, we're looking for the tangent of alpha. So let's remind ourselves that tangent is TOA, which means opposite over adjacent. Okay, opposite over adjacent. So we got 5 and 8. Okay, now the question is, which one's the opposite? Let's not make the mistake that I made last time. Okay, so if we're talking about this angle right here, 8 is going to be the opposite and 5 is going to be the adjacent. So we could say tangent of alpha is opposite, which is 8, over adjacent, which is 5. Okay, so there we go. That's the tangent of alpha. It's 8 over 5, or 8/5. Okay, let's do one more just to make sure we're clear on opposite and adjacent and all that. Okay, so now we're trying to find the sine of beta. Okay, so, and again, remember that this hypotenuse is square root 89. Okay, go ahead and take a second, see if you can figure out what that would be. Okay, and again, I'll set my timer. Hopefully it doesn't take more than a minute. Go ahead and try this one. See if you can find the sine of B. Okay, so sine of B, or beta. Okay, so let's remind ourselves that sine of an angle is equal to opposite over hypotenuse. So, right, opposite over hypotenuse. Okay, and so in that case, it'd be opposite side of beta is this 5 right here. Okay, opposite side of beta is 5 now. Okay, and this is the hypotenuse as always. Okay, so that will give us that that is equal to 5 over square root of 89. Okay. Alrighty, so just a quick side note. We don't have to worry about it for my class, but remember how we were talking about 2 times ago how I could rationalize the denominator? Okay. Sometimes when they report answers for these ratios, they rationalize the denominator. So you'd have to times by square root 89 on top and bottom, okay, which would give you 5 root 89 over 89, okay. So if you see that answer, that's why, okay, because they're rationalizing the denominator. But for my class, you don't have to worry about it for this lesson, okay. So for this lesson, just worry about what is the sine equal to. Don't worry about rationalizing the denominator. Okay. You may have to do it later when we talk about finding side lengths and things like that. But for right now, don't worry about the denominator. Okay, just leave it as it is. Okay. All right. So actually, let's do one more because I forgot there was one more idea I want to make sure we get. Okay. So let's do secant of beta. Okay. And now just make sure, remember, this is not one of the ones that we have the nice mnemonic for, right? It's a reciprocal of cosine, okay? So if you look up what secant means, or if you remember it's a reciprocal of cosine, then secant of beta is not the adjacent over the hypotenuse, but the hypotenuse over the adjacent. So what does that mean? That means we have the hypotenuse on top this time. So secant of beta is not 8 over 89. It is actually square root of 89 over 8. Okay. So just remember that, okay? Don't get these ones confused with sine and cosine. Remember they're the reciprocals of those guys, okay? So just make sure you look that up before you start putting in the fraction, okay? All right, but that should be good enough to get you going on the homework. Again, this will be due next time. We'll grade it next time. And I'm hoping this was simple enough that you don't have any questions. But if you do have any questions, come in tomorrow and ask me and let me know. But other than that, just get going on the homework, and I'll see you guys next time, okay? All right, have a good one.